Hello everyone, I am Usman and I have this problem from functional analysis to explain. So the problem says that show that the closed ball, which is a unit ball in a normed space N, is convex. So for that I take 2 points x and y which belong to the ball and another point x naught and I suppose it to be 0, and x minus 0 and y minus 0 will always be less than or equal to 1 because the difference between any 2 points from inside the ball will always be less than or equal to 1. And now I want to prove I want to prove this ball to be convex. So for that the criterion is that I have to take alpha and 1 minus alpha, where alpha is somewhere between 0 to 1, and if I multiply first point with alpha and the second point with 1 minus alpha, and this x naught, since it is 0, so it doesn't matter if I add it or not, it's just a 0. And if this and this, I take their sum and they belong to the space inside the ball, then they will prove that the ball is convex. So in the next step, what do? That I add alpha x naught minus alpha x naught. So obviously it doesn't matter if I add it and subtract it at the same time. And then I take alpha common between this and this term, and 1 minus alpha into y from above expression, it comes down as it is, and then I take alpha minus 1 common between this term and this term. It gives me this whole expression, as you can see. And in the next step I combine these two terms to get 1 minus alpha times y minus x naught. Now with the help of triangular inequality I can split this whole expression and it gives me this, as you can see. And why have I taken alpha and 1 minus alpha out? Because these are positive constants, and the properties of norm function allow me to take them out with the addition of moduli around them. And since x minus x naught and y minus x naught, their difference will always be less than or equal to 1, so I can obviously add or write 1 and 1 over here in place of this term and this term. So you can see that if I multiply these two terms and I take their sum, it gives me 1, which certainly proves the fact that it is a convex ball because it belongs to the space inside the ball. And that's all about my question. Thank you very much.